Hey, feeling good, like I should. When in dark, I walk around the neighborhood, feeling blessed.
All right, so let's take a look at lesson 4.1.5. This is called checking the connections. And we are going to continue going back and forth between rules and graphs and tables and tile figures. And we're going to look to see what the growth patterns are and the starting points are, the information that we've been provided, and then we're going to create the other representations that would match it. So we'll have a total of 4 representations for each particular example that we're going to be working on, and I think we'll always start off with 2. So let's take a look. It says, in the last several lessons, you have been finding connections and relationships between different representations of patterns. You've worked backward and forward. You've also used information about figure 0 and the growth factor to write rules. Remember, the figure 0 is like your y-intercept, and your growth factor is that number that you multiply times x in the rule. In today's activity, you will use pieces of information from various parts of the web to generate the complete pattern. So you'll be given 2, and then you have to figure out the other 2, basically. So let's just jump right into it. I could read through the directions, but I think you'll see exactly what it is we need to do once I get into it. All right, so you can look on the online book and you can see all of these. Every one of these examples, A, is going to give you 2 representations. In this case, it gives you a tile pattern for figure 3, and it gives you a graph where there's a little bit of information on here as well. And since they've given you the graph and the tile figure, your task will be to create a rule and a table. For part B, you are given actually 2 different points that can be put into a table, and the graphs here shows you can figure out what the growth rate is. So we should be able to look at this information here and create a table from it and look for patterns of growth, and a rule eventually will allow us to, well, I don't know if we're going to do the tile patterns on this or not. I guess we'll figure this one out. Then for C, you're giving us a partial table and a tile figure, and we'll figure out the rule and create a graph and complete this table. Is there anything else going on here? Yes, there is D. Here we've got a rule and a graph, and so we'll have to create a table and a tile figure for this. I might actually, did I just cross this out? I'm not sure. I don't know. Part of me wants to just skip the tile figures and just do the graph, table, and rule, but we'll see how this works out. Okay, so work with me, please. Will you pause and copy down this exact tile figure? Call it figure 3. There's a block of 9 here, right? A 3 by 3 9. So that's a square, and then there's 1, 2, 3, 4 in the tail. Then create this table, or I'm sorry, this graph. So it looks like you're counting by 1s here, and you're counting by 3s here. And I'm not exactly certain what these points are right there, but we're going to figure it out once we create the table, this information, because I already know something here. I know what the growth factor is. I'm not sure what the rule is, but I'm going to figure out what the rule is once I figure out where my figure 0 is by taking this growth and this figure and working our way backward. Okay, so go ahead and pause and create a table, and when you unpause, we'll get started on this. All right, so keep in mind that all these are our x values, all these are our y values, and I'm going to say 0, 1, 2, 3, and 4. I know that it says 9, 10, 11, 12, 13, and based on this growth triangle, we know that the change in y is equal to 3, and the change in x is equal to 1. So that means that the growth rate in our rule is going to be 3. So that means that to go from here to here, we're adding 3. To go from here to here, we're adding 3, and so on and so forth. So that means this must have been 10 because that's 13 and it grew by 3, correct? And this has to be 16, so that means that this would have been 7 and this would have been 4. So now we've got our y-intercept and our growth rate, so we can now write the rule. The rule is y equals 3x plus 4. And I believe that completes this part. We had to create the table and the rule, right? So that's going to be our rule. Now let's make sure that it works for our figure. If you take figure 3 and you multiply that times 3, you get 9 plus 4 is 13. So that is how many we have here. And does it look like, we already know that it has a growth rate of 3 because that's how we generated our growth rate. But does that look like that could be where y is equal to 4, right? 3, 4, 5, 6? It absolutely does. So I feel confident we've got the correct table, we've got the right rule. All right, please copy down what you see here. Pause. We're going to find a rule and a table, and I think we'll just skip the tile figures because I honestly don't want to create a tile figure with 58 or 31 tiles. I think you do not want to do that either. All right, so let's pause and come back when you've got everything drawn in. All right, we know two things here. We know this point right here is where x is equal to 4 and y is equal to 31. We know this point right here is where x is equal to 7 and y is equal to 58. So if I were to create this table, we could probably figure out what the growth pattern is from the table. I don't want to do that. I would rather say our growth rate happens when we figure out the change in y over the change in x. In this particular situation, the change in y, how much does y go up from 31 to 58? Well, let's take 58 minus 31 and see what we get. Looks like we're going to get 27 out of that. And how much does x go up? Well, from 4 to 7, it goes up 3, correct? Because we would take 7 minus 3. So what I'm showing you right now actually is a part of what we call the slope formula. What is that supposed to? No, that's supposed to be 7 minus 4, isn't it? Hold on. Let me get this right. That's going to be 7 minus 4, so this is going to be 3. Where find the slope of the line, you take y2 minus y2 minus y1 over x2 minus x1, where these numbers are like, this is the second point, this is the first point. So this would be considered y2, and that's x2. This would be considered y1, that's x1. So that's precisely what we did. To find the difference, or how much this went up, right? That was a basic subtraction problem. 58 minus 31 is 27, so this must have gone up 27 units to go from here to here. So what is our slope? Our slope ends up being 9. That's our growth factor. So if I know that 4 is 31, and we are growing by 9 every single time, that means if I go backwards, I'm going to take away 9. So that means this must be 22 for 3. This must be 13 for 2. This would be 1 is 4. And then what is 4 minus 9? I think 4 minus 9 must be negative 5, correct? So that means that our rule must be y is equal to our growth rate, which we found here, 9 times x, it's growing by 9, and then what is our y-intercept? It's negative 5, so let's put minus 5, or plus a negative 5. Now, how do I know that this is correct? I'm going to check this point right here, and I'm going to check that point right there. Let's start with 4. What is 9 times 4? It's 36. 36 minus 5 is 31. Check. My rule works for this point here. Does it work for this one? 9 times 7 is 63, and 63 minus 5 is 58. Check. We've got the correct rule. So you can be given partial information, and you can use that partial information to figure out a lot more information. And based on what we know about growth and where we see it in tables and in rules and in graphs, we can now transfer information from a graph into a table, which allows us to find our y-intercept, which we then put into the rule. And now we're going to use this to solve problems. All right, so what do we have here? We've got a partial tile figure, and we've got a partial table. And what we're going to do is we're going to figure out what the rule is, and we're going to graph it. Now, how do we figure out what the rule is? Well, maybe we should start with the graph. Since I know that this is figure 8, and it has 2 tiles in it, and this is, says figure 3 has 12 tiles, I now have 2 ordered pairs that I can plot on a graph. And if I have 2 points on a graph, I can form the line. Okay, so what I'd like for you to do is copy all of this down, copy a graph, and I think all we really need to do, well, no, we're going to have to go up a ways. So maybe have your graph, have your y-axis go up to maybe 24, and have your x-axis just needs to make it out to 8. Okay, go ahead and pause, and once you get everything labeled, we'll plot these points, and we'll see if we can derive the rest of our points in the rule from the graph. All right, so I decided to count by, have each one of these by 3 so I could get up to 24. I don't know that we need to get to 24. I just don't want to make a mistake of having to do it over because I didn't go far enough up and we couldn't find our y-intercept. So let's start plotting these points. We're going to plot, I'll do this in red. Let's take 8 is about 2, which would be right around here, and I'm going to go ahead and label that 8, 2. And then this is 3, 12, so we'll go to 3, and then 12 is going to be right here. 3, 12, and now I'm going to connect these points with a line, and I'm going to have that line go all the way through for my y-intercept, which looks like it's going right through the 18. Okay. So let's figure out what our growth rate is. This is definitely going to be a negative growth rate because it's going down, right? As x increases, y goes down. So what is happening here? The change in y is that it goes down by 10. And the change in x is that it increases by 5. So what is negative 10 over 5 the same as? The slope ratio is negative 2. So that means that to go from 13, actually let me just do this, 3, 12, and 4 should be 10, and 5 would give us 8, and then 6 would give us 6, and 7 would give us 4, and sure enough, 8 gives us 2, which is the information that was provided here. So all of these points could go on our table, but didn't have us make our own table. So now let's work it in reverse, which means this would have to be 14 because we're going backwards. This would have to be 16, and sure enough, this would be 18, and that's what I was thinking. Our y-intercept appears to be 18. So if the y-intercept is at 18 and our growth rate is negative 2, what rule is this? This y equals negative 2x plus 18. Now let's make sure it works here. Negative 2 times x is negative 2 times 8, so that's negative 16. And negative 16 plus 18 is positive 2. Yes, that works. How about this one right here? Negative 2 times 3 is negative 6, and negative 6 plus 18 is 12. Yes, that works. That means this is the rule that applies to this situation. And now we can take any value for x, plug it into this rule, and get an answer for y. And now for the last one. This one, they've given us the rule. So this actually should be a little more straightforward. You notice how they've already given us our growth rate, and you can see it here. Let me just go ahead and set this up. The change in y over the change in x gives us our growth rate. And here it says that y is changing vertically by going down 3, and x is changing horizontally by increasing by 1. Okay, and just this point here is at 0, 7. This point here is at 1, 4. And so you can see when x increased 1, y went down 3. So that's how we get our growth rate is actually -3. So now looks like 0, 7 must be our y-intercept, correct? This point right there. And that's our point right there. So go ahead, complete this graph. I'm going to delete everything here. Go ahead, copy this rule down, copy this graph down, and then complete the table. Go ahead and pause, and when you're done with everything, unpause, and we'll check. All right, let's take a look. Our y-intercept is at +7, so when x is equal to 0, y is equal to 7. When x is equal to 1, since our growth rate is a -3, we need to take away 3 from 7, and that's going to give you 4, right? -3 plus 7 is 4. When x is 2, that becomes a -6. So y ends up being 1, since -6 plus 7 is equal to 1. And if x is equal to 3, that's going to become -9, and -9 plus 7 is -2. And we see the pattern there, the trend. 4 gives us -5. And we could keep going with the table, but we don't really need to because we've got the rule. Now, one last thing to check. Y-intercept is at 0, 7? Yes. This point is at 1, 4? Yes. Is 2, 1? Does that appear to be located in the appropriate spot on our graph? And the answer is yes. This looks like x is 2, y is equal to 1. And then 3, -2 could be right around there. That looks about right, given that -2 would be right around here. So we feel good about our table, our graph, our rule, and we did not make tile figures here because that would have just taken too long. And we're done with today's lesson. So hopefully at this point of chapter 4 and all the other work we did throughout, I guess it was in chapter 3 when we first started working with these 2 variable rules, you should now be able to look at any situation, any table or any graph or any rule, and be able to identify what is the growth pattern, what is the growth rate, what is the starting point, and then use that piece of information to answer other questions. Okay, all right, let's move on to the next activity. Probably either a connect or a check for understanding or heading over to your homework. Take care, bye.
Hey, feeling good, like I should. When in dark, walk around the neighborhood.